Hello guys, myself Ashish, and today I am here again with my project, which is about heart detection machine learning model. This project is a part of my internship with Mentorness as a machine learning intern. The data was given to me by the company, and with the use of that data, I have to make a machine learning model, and all the information of creating the machine learning model or about the creation of model I have attached in that ppt in this ppt. This is the first introduction page that this presentation will explore the development of a machine learning model to detect heart attacks early. Means we can early detect the heart attacks. We will cover the key steps from data collection to real world deployment and discuss the ethical considerations and future potential of this life saving technology. The second slide is about the introduction to heart attacks. Means what is the heart attack? Basically, as we all are very aware about the heart attacks, a, a heart attack occurs when the blood flow to the heart is blocked, often due to a buildup of plaque in the coronary arteries. Means whenever the blood supply is blocked to the heart, then there will be a heart attack. And this is all of and these problems are all of the due to the building of plaque or say the fat in the arteries. These are the symptoms, like some common symptoms for the heart attack are chest pains, shortness of breath, nausea, and cold sweats. Then the third one is the risk factors, means the key risk factors that will majorly participated or say the major causes of the heart attack are high blood pressure and high cholesterol, diabetes, and unhealthy lifestyle choices. So this is the data description that was given to me. So these are the some of the attributes. The first attribute is of the age, like what was the age of the patient. Second one is the sex, like what is the sex of the payment, like for the male it is 1 and for the female it is 0. uh, or we talk about the data set. In the data set, the sex column was given to me was a categorical form. Here the male and female was given to me. And CP is the chest pain type, and this is the 3 tablespoons, means the resting blood pressure. And this is the cholesterols. These are the FBs, like fasting blood sugar, and the resting electrocardiographic results, maximum heart rate achieved, the exercise induced angina, and the depression induced by exercises relative to rest. So overall, these are the total attributes of the data that was given to me. Then the first step of creating a machine learning model is always the data preprocessing. So in the first of the step, I will try to find the missing values. But as you can see in the picture, when I check the null values, there is no null values present in the attributes. Means in the age attribute there are 0, in the sex was also 0, CP 0, TET, TVPS 0, col 0. Means all of the attributes having 0 null values. Then the second is the encoding categorical variables. Means we should ensure that if there are categorical data was given, then we can convert them into the numerical form, because our system was unable to read the text, or we can say unable to interpret the text. It always saves the data in the form of 0 and 1. We will encode the we will encode the sex column. Means we have mapped male as 1 and female as 0. So in the second step, we will split the data into x and y. So in the x, the all of the data was first in the x. So in the x, what we will do, we will draw the target column from the X, and then in the Y we will save the target column. Means target, there was also in the target 0 and 1 was given, means 0 for the 0 for the no risk of heart attacks and 1 for the risk of heart attacks. So then in the second step we perform some exploratory data analysis tricks. So there is this is the uh, correlation heat map which I was created. So as we all know, the matplotlib library and the seaborn library. So in the first step I will import both of the libraries, and actually there is no need of matplotlib. Simply with the help of the seaborn we can create the heat map. So there are the attributes of the data like age, sex, CP, coal, FVs, and slope, CA, all. So as the dark is the color, we can see the minus is the value, means there is highly negative relationship in between the features. As we can see, the color is getting lighter and lighter. The correlation among the features was increased. So in the third step is the splitting of the data and building and training of the model. So I have used the train and test split technique. So I have split the data into 80-20 ratio, means 80% of the data I have used for the training and 20% data I have used for the testing. So I have tried many of the algorithms like XGBoost and gradient boost also. But among all of them, the most of the accuracy was given by the random forest classification classifier. So that's why I have make the PPT with the random forest classifier only. So the mode so so the algorithm that I used is a random forest classifier. So there is one more thing was to notice that I have used the standard scaler. What the standard scaler is doing means, as we can see in my data, there are very big and small values in the data. Like we can see, this is a 37 and this is the 63. Like in the cholesterol also, there can be the cholesterol of someone is 180 and the cholesterol of someone is 270. Means there will be some high values and the lower values, then there will be chances of bias will increase. So we will use the scaling, means we will scale the data into a standard format, means there will be no bias generated by the data. That's why we are using the standard scale. So we will scale the training data and testing data also. Then we will create the model equals to random forest classifier, and the estimators we have used is 100 and the random set is used by us is 42. So we have trained the model X train and Y train with the help of X train and Y train. So this is there is again some explanation about the building and training of the model. Like we chose a random forest classifier for this model due to its robustness and accuracy. We set the number of estimators to 100 and used a random set of 42 to ensure reproducibility of results. Before training, we standardize the features to ensure all variables contribute equally to the model, and the training process involved fitting the random forest classifier to the training data. So the first step is the model evaluation and the prediction sample. So there are the some evaluation metrics like accuracy scale, accuracy score, the confusion metrics, and the classification report. So the model was evaluated using various metrics. The more accuracy score was approximately 87%, as we can see in the as we can see in the picture also. Accuracy score is 0.8688, which is almost 87%. And we can see in the confusion metrics and classification report also, which provide us some details detailed insight into the model performance across different classes. So, who don't knows about confusion matrix and classification report, you have to read by yourself, and then you will make understand then what is the classification and confusion matrix. So then I have make some prediction, not some. I have make a prediction with the data, with the patient data. So I have used the data which is saved in the variable example underscore data. So I have used in the form of an array, and I will transform that example data, and then after the transforming, I have predict the example data. So then I have put an if and else statement also, means if the example data is comes equal to 0, then patient will indicate no risk, and if the value of the example data is comes 1, then the patient will indicates risk of heart attack. So as we can see, the values will be equals to 1, as the output is patient indicates risk of heart attack. So the last one is the conclusion. The future directions, means the heart attack detection model was developed using a random forest classifier that will which demonstrates significant potential in pretending heart attack risk with the accuracy of 87%. Means the accuracy of the model was 87%, and the dataset was sourced from the UCI machine learning repository. Actually, it was provided to me by the company, so I don't know from where the data was come or not. So there are some features explained that was already in the dataset, like age, sex, chest pain type, cholesterol levels. Then there are some categorical variables also, like sex, and then I will do some exploratory data analysis, and then I will scale the attributes also. So in the last, I have evaluating the model accuracy with some evaluation metrics like confusion metrics and classification report to highlighted the robustness of the model. So future work will focus on enhancing accuracy by incorporating more diverse data and exploring advanced algorithms. So I am aiming to improve early heart attack detection and prevention strategies. So this is all about the model, and thanks.